guys. So we are kicking off a webinar again. This time it is about when IPv6 will replace IPv4. There are many debates about it, but we will look closer to where we are today, and we will try to analyze data and development obstacles around the IP ecosystem. So let me begin by introducing today's speakers. John Sweating, Chief Customer Officer at ARIN. Lee Howard, Senior Vice President at IPv4 Global. Jack Beech, Vice President of Business Development at IPXO. We have also Paul Rendek, President at Dstream Group, but apparently he has some difficulties joining our webinar. And myself, Vincentas Grinius, co-founder and CEO at IPXO and Hefeist. So perhaps John and Lee, could you give some background information on the IPv4 evolution? Why was the internet not ready for the IPv6 from day one? Also, any interesting facts that are important to understand the whole picture of it?
Yeah, so I guess, Lee, you're going to jump in there and do what Paul was going to do. So you're going to do IPv6. I'm just going to really quick go through IPv4, the history of it, where we're at, and how we got to where we are. So I'm not sure, I'm not going to cover a whole lot of the early history, but in the 1960s, ARPANET began working on packet switching project, which resulted in TCP/IP and the packet switching and email. Not a lot of people know email started way back then. I think I had my first email address in 1981 when I was in the U.S. Army. So all through the 70s, the protocols were designed and developed. You might have heard of Vince Cerf and his partner in crime. That developed all that, going all the way up through to 1980 when RFC 760 created IPv version 4, or defined IP version 4, which is what we call IPv4 today. In 1981, IETF updated that draft to RFC 791. Lots of developments through the 80s with the domain name systems. IANA being founded by John Postel under RFC 1083, and of course the World Wide Web being developed in 1989. Going into the RIR systems. So at this point in time, there's Paul. Just in time, Paul.
Hello there, everyone.
Right there in time.
Thank you.
So in going through the RIR, so in 1992, RIPE was formally established. Paul probably knows a lot about that, but he'll get there on the IPv6 side. 93, APNIC was founded, and during this time, John Postel was actually managing all the IP addresses and stuff through the IANA. So as far as North America and that, he was actually the one doing that, doing the management. And his little black book that people have heard about. Then in 93, so at that point in time, okay, people are saying, okay, this was developed as a research project by the military and the government, U.S. government. It was never imagined that this was going to become what it became. So as it started taking off in the early 90s, and the world, the global communities started adopting it, people became aware that, hey, these 4 billion addresses, of which there's not really 4 billion because some are reserved for special projects, they're not going to last long if this thing catches on. So they started doing things to prolong it while they developed this other protocol through the 90s, which is IPv version 6, which Paul will be talking about. I do want to mention, because a lot of people always ask, well, what happened to IP version 5? IP version 5 was a protocol. It was a stream protocol. It failed miserably, I understand, and it was never publicly announced or shared. So there was an IP version 5. So a lot of people say, I don't think there ever was one. Yeah, there was one, but it failed. So there was some things that people started looking at ways to prolong IP version 4 because it started out as classful, which meant you know, if you needed 258 IPs, then you had to go all the way from a class C to a class B. If you needed a little bit more than what you got in a class B, which is /16, then you had to go all the way and get a /8, which is a lot of reason why the existing legacy blocks are mostly 24s and 16s, and that's why a lot of people ended up with /16s during that time, because that's what they could get. And that's going to lead into the transfer market later on, and when we get talking about the transfer market. But for now, that's good to know. But then they say, well, we're gonna really run out quickly if we don't do something about this. So they came up with the CIDR, classless internet domain routing, and that started preserving. You know, that RFC 2050 came out and told how you give the space out, how you conserve. I mean, conserve was the big word. I don't know how many times I was told by Kim Hubbard whenever I came to prior to ARIN, to Network Solutions, asking for address space. Oh, you can't have that much. Here's how much you can have. We have to conserve this stuff. This is very, very special space, and we're going to run out, and you gotta jump through hoops, and it was very difficult to get space. I actually started out. I was working for Internet MCI at the time, and that I first started getting introduced to the RIR system and trying to get address space, and it was very difficult. RFC 2050 was difficult in its own to meet those requirements, but when you went to the RIRs, it was extremely difficult to get address space.
It was almost like a balancing act between actually the growth of the internet and making sure that we could actually conserve the address space once we found out that we were going through it so quickly. So what were you doing? Were you actually holding back the development of folks kind of bringing companies and people onto the internet versus saving the address space? So that balance was quite difficult, I think, for the RIR system to get right. You know what I mean? Yeah. And there were some dips, and there were some periods that were very difficult, I think, for the RIRs in coming up with that balance at the time.
Yeah, and it actually led to a lot of policies. Well, I was going to talk about NAT. NAT came along, network address translation came along. That was another thing to prolong IPv4 until we could get IPv6 out the door. But because of the conservation practices stuff and RFC 2050, it was very difficult for not just anybody could go to the RIRs and get address space. You actually had to be able to. I don't know about the policies everywhere else, but I do know in ARIN, you had to be able to at least qualify for a /19 in order to get any address space directly from the RIR. So there was these separate classes of citizens. If you were just a little small ISP or an end user, you couldn't get your own space. You had to get your space from your provider, and those big providers of the day were the only ones that could actually go in and get the space. As I said, I was working with Internet MCI, and we were qualifying and getting a /12 every 3 months. Wow. That's just how fast it was. It was back in the days of the T1s, and everybody had a T1. Actually, FRAC T1s were actually the standard in the late 90s. And so a lot of address space, a lot of customers were connected, a lot of address space was given out. ARIN, so in 94, NAT came out. That was another way to prolong IPv4. ARIN came along in 97. LACNIC in 2002, EFRINIC in 2004. And everybody was happy. They were getting their address space from IANA, and they were giving it out to their communities. Communities were developing the policies. Vendors had a lot to do with the policies because There was a lot of worry about the memory and how big the global routing table could become. So a lot of the policies were shaped by vendor equipment and the capabilities of that equipment. But then it started 2009, 2010. People started talking about the transfer market. Policies started coming up in the different RIRs. I think ARIN's first transfer policy was approved in 2009. When we got to 2011, IANA gave out their last /8s to each one of the RIRs. They had 5/8. They gave 1/8 to each RIR, and IANA was done. They were not giving out any more IPv4 space. And also in 2011, the first transfers were completed. The first transfer was completed, I believe. Most people claim that the Microsoft Nortel transfer was the first approved market transfer or commercial transfer, depending on what you prefer to call it, was approved. And APNIC also approved the first inter-RIR transfer. Of course, it didn't do a whole lot of good because they were the only ones with an inter-RIR transfer at that time. 2012, ARIN and RIPE approved their inter-RIR transfers and began transferring between the different RIRs. LAPNIC has an inter-RIR transfer policy that they just put into effect last year.
Correct.
Yeah, so the RIR exhaust, it was 2011 APNIC, 2012 RIPE, 2014 LAPNIC, 2015 ARIN. I don't believe AFRINIC is exhausted yet. They still have a free pool. With all of that, there became these. There was a lot of soft landing policies, last/8 policies. ARIN never had a last/8, but we had special reserve policies for transition to IPv6 and stuff. So that's kind of a quick overview of where we ended up today with the transfer. We're in the transfer market now, and because of all these things, IPv6 is still it's gaining. But it's still trying to really be fully accepted and deployed out there in the world. So I'm going to turn this over now to Mr. Rendek, and he's going to go through the IPv6 history real quick.
Right. Okay. Thanks very much, John. Yeah. See, it's very interesting. I think at the time when V6 reared its head, I think that the internet world was still getting its head around how it was supposed to be working with IPv4 space at the time, and the massive growth that we were seeing there. I don't think the attention was quite on IPv6. If I remember joining the RIR system back in 1998. We were very much focused on trying to bring about and service the networks that were picking up the IPv4 space. And then within that time span, I think within a year of me being in the RIR system, this thing called IPv6 started to rear its head, and it was just a whole new set of numbers there that I don't think anyone was quite looking at. And I think normally what happens is that, when you extend technology and you understand kind of what's happening, engineers tend to work together and find a solution for extending what's happening. I think that the world was so busy growing when IPv4 that when IPv6 came about, I don't think there was that kind of energy or synergy in how was this going to work to extend the internet, and how would this work for engineers and kind of bringing new folks onto the internet. So I think largely from my experience, I could see that IPv6 was very much ignored at the beginning. And I think in 2000, when the RIRs launched these large campaigns, promoting V6, and obviously we were seeing that the run out of V4 was going to come at some time. I think everybody was just basically looking at growing their network and seeing where they were going, and not paying attention to this new thing called IPv6 that had reared its head. Despite quite a lot of efforts from the internet community, discussions and a lot of focus put on on deployment of IPv6, there really was no movement happening. I would say from 2000 to 2010, the first 10 years, minute. In fact, there just wasn't so much discussion. It was the RARs talking about this quite repeatedly, but the actual internet industry not touching it. Probably somewhere around that 2008 to 2010, just before that run out, there was a bit of a push in the V6 area where, there was a lot of uptake of allocations given out to the organizations, but the organizations actually weren't doing anything with them. They were sitting on the allocations and still moving forward with the IPv4. And I think once we started moving towards that, the run out of the IPv4 space, I think everyone's attention was focused on how they were going to receive as much IPv4 space from the RARs as they could before this pool actually ran out. Okay, well, we can see that we had the extension that came about, which John was talking about. There was, obviously everything was geared down to where each new LIR that came on board had a much smaller allocation than what was being given out before. But that still didn't turn anyone's focus into looking at IPv6. Why is that? I mean, I think as we were going along, I think, we're going to talk about this a little bit further in some of the other sections, but I think that, the new technologies to preserve or to kind of optimize the IPv4 space, and that coupled with, a lot of older technology still out there on the internet through this whole phase has really kept anyone from looking at IPv6 seriously. I mean, there is some growth happening there. We're going to talk about that. But I think nobody sees that need from the bottom line. So I think this is where we are today with the V6.
Right. Thank you, guys. And great recap of the history. Right. But do you agree that IPv6 adoption correlates directly with the IPv4 usage? Is it the case?
No. So the growth of both over time seems to be roughly linear. So they correlate more or less to the internet growth. But just because somebody is using IPv4 doesn't mean they're using IPv6 and vice versa. Anecdotally, in the transfer market in our business, and this is anecdotally, I don't have data to support this, but what I see is that companies that are buying IPv4 addresses tend to be deploying IPv6, and companies that are selling IPv4 addresses aren't really thinking about it very much because they have a surplus of IPv4 addresses. They have no scarcity, so they don't have quite the same drivers.
So, but if we would touch, let's say, the economics, on IPv4, because IPv4, it's skyrocketing in terms of the pricing, right? So, do you think that, considering the prices of IPv4, do we reconsider adopting IPv6?
I haven't. I keep asking people that. Go ahead.
So I actually wanted to touch on this. That's a very good point, Vincentas. When you're saying that the IPv4 space is skyrocketing, I think it's actually moving up steadily as we're going along. I don't think it's skyrocketing to points that are quite alarming yet for network operators. I think there is a threshold out there. There will be a price tag where eventually networks will say, from the bottom line perspective, and from actually being able to service the customers I need to serve, I will need to be deploying IPv6 or taking a look at what my network needs. I don't think that we're quite there at that point. And if you look at the number of maybe users coming onto the internet, let's take a look at some of the figures, right? I mean, Jeff Houston's bits that he publishes on Podaroo are fantastic. We can see that we've got growth, and I mean, I'm working a little bit, taking a look at some of the areas of the IXPs. I'm seeing that their traffic is growing and has grown quite heavily, actually, over the pandemic period. Has the actual number of users coming on board on the internet increased the same way? No, it hasn't. Actually, the internet in 2020 has increased at a declining rate from the usage of bringing users on board than we would have seen in 2018 and 2019, right? So while traffic would have been increasing, yes, the pandemic would have had something to do with that. I don't think we've seen that the number of users has grown in the same way, right? So that scarcity of networks taking a look at why they would move to V6, again, just wouldn't be there for that point, right? And if I look at prices, you know, where I've seen, okay, recently I've seen some prices that have increased a bit, probably, you know, about an 8% growth. I think Lee can give a much better figure than I can here. But when I look at over time, the exhaustion of the space and the pricing that's come there, I don't think it's so strange.
Yeah,
Well, right.
Vincentas, I would just like to add that you know, it's all relative. It's for some of the people that are buying the larger companies that are buying up the IPv4 space. They're making an investment and purchasing that. But
True.
You know, if you've got 20 million customers and you raise their rates 50 cents a month, you're bringing in $10 million more dollars. If you go and say, hey, we got to charge you like $1 more a month because we're going to give you some IPs, like, and you're going to pay off what you spent to buy those IPs rather quickly, and then you're going to have this new revenue stream coming in that's all profit. Because,
well, yes,
Right.
yes, but that's when you think about the subscription service like cable or fiber to the home or something where you're expecting to pay, you know, 50 or 100 euro. Maybe some of you are lucky to be in countries where it's cheaper than that. Or cloud, right? But when you're talking about a mobile service, especially in a lot of countries, you're talking about a monthly subscription that's a few dollars a month. And so
Right.
$5, $10, $20 a month, you add $1, that's an ISP or a mobile carrier that may lose a customer to somebody else. That buying one IP address, you can't buy one IP address per customer. So they all do some kind of address sharing, and that's actually part of why T-Mobile, for instance, deployed IPv6 was because their cost of NAT was so big. They were spending so much money on NAT boxes. They needed to deploy IPv6 so they could cut their NAT expense in half or more.
yeah.
Hey guys, I don't want to steal thunder from a little bit later, but don't you think too, we kind of know who the big whales are sitting on a lot of this V4 space, right? And I think that we're arguably around 30% adoption on V6, but as we start to gain more adoption of those V6, especially with the bigger entities, we're going to start to see a lot more of those IP V4s come to the marketplace or come to the market, right? So I think that it's like a sports card. Right now, you've got scarcity. There's not a whole lot of it. And you have, you know, the bookstore out there buying as many as they possibly can. They're the second largest holder of V4 space. But at some point in time, when that space, when they start to make that transition, you're going to have a flood of additional V4 space that comes onto the market. And I think that that's what's going to kind of depress pricing a little bit. I think we're at all-time highs. Maybe we go a little bit higher, but I think that we'll start to see pricing come down a little bit, especially when you have a vehicle. I'm stealing thunder for the last half, right? But a differentiator, people might not want to sell their space, but now that you can lease it out, drives a totally different market and a different pricing point.
Right.
In commercial terms, it depends on whether you're making revenue on the addresses. So obviously, the U.S. Department of Defense doesn't really care. They're not highly motivated by selling addresses for dollars. That's not how they work. But any other commercial company, they're going to look at what does it cost them, and not just. And so there's opportunity cost. There's the actual labor costs, renumbering in order to make addresses available. And for a lot of them, it's just the pain that they potentially cause their customers that they have to renumber some kind of EDI system, or if they have to renumber, you know, industrial machinery that barely speaks IP at all. Those things are really hard for them to do, and they just don't want to look at the risk. And you have to have some really astronomical numbers to make it worth risking their primary business in order to sell addresses. When you compare it to some of the ISPs that have acquired addresses through M&A, okay, they're just sort of making the business decisions, trying to decide how are they going to maximize their returns while making sure they don't have to, you know, cause their customers pain.
Yeah, and
Absolutely.
point to Lee's point, another group that fits in there is the research and education field. They have a lot of those early Class Bs I mentioned, those /16s, and they didn't manage them, you know, perfectly, and so they have usage like spread out across the full /16, and you know, they try to they get calls from people like Lee and the other facilitators. Hey, you've got all these flash. You could make some, millions of dollars off this. And then, so the higher ups that get contact, they call down the engineering department and say, hey, is this true? And of course, the engineers, they don't want to do all this work. They're not going to get paid anymore. So they're like, well, yeah, we maybe could do this, but it's a hell of a lot of work. And we've got all this other stuff you're asking us to do to keep the network running. We really, there's really no reason for us to do it. And basically they get turned away. And that's why you don't see a whole lot of movement in that realm.
That's a really good point. And I think probably one of the big ones that we're going to butt up against the most, right, is they don't want to have to go back and re-subnet allocate, split networks.
It's astonishing how many of those guys have never thought about CIDR. Every network gets a /24 because that's how we've always had a class B. That's just how we allocate networks. And the idea of /27, boy, math is hard on that.
Yes.
So if we take a look, actually, because I'm seeing the numbers. I mean, the transfer market probably speaks for itself. And John, you can comment on this from ARIN's perspective because you've got these figures in your head. But when you take a look at the transfers that were done just in ARIN alone, and you take a look at larger number blocks, and then you take a look at the smaller number blocks from /20, let's say, or /19 downwards, what are the kind of figures that we're seeing there?
For 2020, I actually have a slide up here on 2020. For 2020, the full year, the number of /24s that were transferred as a /24, it was 394. Then you go down to /23s, there was 157, /22s 159, /21 is 101, and it just goes down from there until you get to /16, and then it pops back up to 129. But we know why that is, and then it goes way down. For 15s, it's 5, 14s 3, 13s 2. It just goes away. But the big
single digits.
Yeah, the activity is at the smaller blocks, and it really is. There's a lot of people out there, the smaller people, and they're not recouping their cost per se, like Lee was talking about with the big cable companies or the big cloud providers, but they're gaining customers, so they're gaining revenue, and they're making up for that. And plus, most of them, a lot of the smaller ISPs and the WISP, the wireless ISPs, and they were actually paying through the nose to their upstream provider. The big guys out there that actually had the space in the beginning, they were paying through the nose for the space that they were using anyway. So for them to get their own space, it makes perfect sense.
Right. Okay. So when you look at this,
go on, Paul. Yeah.
Sorry, go ahead. You know what, Vincentas? I just wanted to make a comment on this because I just quickly did some tallies on those numbers that John gave us. If I'm looking at it, I'm looking at like over 800 transfers in the ARIN region happening at /20 or less. So what is that telling us, right? Like, because we've seen the statistics for the overall growth of users on the internet, which is growing, but at a bit of a declining rate from 2018 and 2019. Okay, but we look at this, what I would call a fairly large number of the smaller blocks being transferred, right? There was a lot of activity on /16s happening in 2018, 2019, very large chunks of /16s being showing up on the transfer market. John just pointed out, and we're talking about ARIN here because these are the figures that he has at hand. Yeah. Then he's at about 129 of the /16s. That makes sense to me. But what are we looking at when we look at these smaller numbers? I could see at the RIRs that towards the end, you started to have quite a few speculative LIRs or speculative kind of members coming on board taking IP addresses. And I'm wondering if some of these smaller chunks isn't a consolidation of some of those of the last digits that were being handed out, which you must hold on to for a 2-year period. After that 2-year period, you could transfer those resources. I think what we're seeing happening here in 2020, I may be wrong, but I think what you're seeing here is that there is some consolidation of those numbers. They're going back into the internet. They're probably being used by networks that are using them, but they're not really increasing the number of users on the net. So what's happening with the numbers here in that transfer market? It's very interesting.
So I think Reg NCC in particular did create a policy environment that made that kind of speculation a little easier to do. I also, and you're right, it's been a couple of years. So
yeah, that's correctly, yes.
The hold down periods are now
correct.
expiring. And we're seeing a fair number of buyers who come in and say, I need a large amount of space, or I need ongoing returns of address space, but because they're often either there isn't supply all at once, and they can't just buy a /16 or a 14 or whatever they need. So they're buying 19s and 20s and 21s over and over and over. Or they just don't have the cash flow. Like they're a growing network, they're deploying, a wireless ISP or a satellite network or something, and and so as they grow, they're buying more addresses in order to feed their individual growth. That's part of what I'm seeing, where I'm seeing that come from.
Yeah, and some of that, Lee, is driven by policy. They have to be approved, at least in the ARIN region. They have to be approved for whatever block they're going to transfer, and so sometimes they have to do smaller chunks because that's all they can get approved for at that time.
I do have a chart where the average number of addresses per transfer has declined over time. It used to be in the 10 to 20,000 addresses per transfer range, and now it's well under 5,000 average.
Yeah, I can throw out a couple of quick numbers on that. So in 2017, we processed 1,373 transfers that included 37,736,448 IPs. And in 2020, we processed 1,940 transfers that resulted in only 17,745,000. So the number of transfers went up 6,000, but the number of IPs involved in those transfers went down 20 million.
And just to set, guys, we got a lot. I think we have over 100 people on it. Just to set the definition, when we talk about transfer, we are talking about transferring a physical ownership of those blocks. For anybody out there listening to us. So.
Well, John, would you like to define that precisely? Is it RIR?
That's fine. Jack can call it ownership. I won't call it ownership. I'll call it the right to use. The right to use.
There we go.
And have it in the who is.
There we go. We'll go there. There we go.
But
what's funny, kind of going through the who is, by the way, I started an ISP back in '91 when everybody asked, how are you going to compete with CompuServe and Genie and everybody else, right? We got our own blocks, probably 95, 96. And the housekeeping is something that needs to be done, because I can go back into the tables and I still see the entity that I formed back in the early 90s as the record keeper of some of those blocks, right? So,
In doing the research on the provenance of that old space, I'm sorry, the transfer market is so exciting that it's hard to get around to talking about IPv6.
I know. But we should probably get
I would like to actually get you back to the main topic right now, because I see that we are getting too excited here. Right.
Sure.
First things first. What about the technical obstacles adopting IPv6? We have routers, switches. We have, dual stack things, Is it all irrelevant, or do we have, or even not? Is it all irrelevant, or are there any other obstacles that actually is slowing down the IPv6 in terms of the technical perspectives?
Before I was doing IPv4, I was doing IPv6. I was the IPv6 person at Time Warner Cable. So the biggest hurdles that we had were with things like routers and security devices and applications. Boy, there's just a lot of time customizing especially our in-house applications like our IP address management system and our DHCP systems and all of those kinds of provisioning systems. But we took care of those. I mean, that was a lot of labor. It wasn't exactly hard, but it was. But we had to do it. What came up after that is it's all the things that don't support IPv6 tend to be the in-home devices, the consumer electronics, or and of course a number of websites. But that's not a technical barrier. That's just a support. What hasn't supported it yet? From a technical perspective, I think a lot of people think that IPv6 is harder than it is. And I think that it's no harder to learn how to deploy IPv6 than it is to learn any other protocol. Like if you had to figure out how to configure OSPF, you can probably manage IPv6 with about as much effort. But if there are technical issues, it's going to be around things like maybe multi-homing, because you can have multiple IPv6 addresses. If you have 2 exits, you're no longer using a stateful firewall or even NAT to figure out which to maintain state. And so making sure, so how are you doing announcements? How are you making sure that your return path is the same so you establish state? That's a little, there's some work at the IETF that's helping that. It's getting there. A lot of people have some security fears. I think they're mostly misplaced, but we can talk about that a little bit more. There's, most of my experience with IPv6 is that it's not that hard. It's just labor intensive, really.
The 3 things that I posed that I wanted to get a question on, right? You touched on the one, and that's really kind of the lack of IP or v6 capabilities with some of the older electronics, if you will, right? What about backward compatibility? And it's not technically, well, I guess I kind of put it in the technical challenges, but the expense. It's almost like if every country doesn't get on board with it, or majority of it, right, then you're going to have disparity on IPv4 and IPv6. Who carries the cost burden, right? So what about those 2 things?
The economics are, as far as an externalization of costs, it's kind of brutal. It's the people who aren't deploying IPv6 are driving up the costs for the people who don't have enough IPv4 addresses. Because if I don't have enough IPv4 addresses, my choices are buy IPv4 addresses, buy NAT boxes, or deploy IPv6, and probably deploy IPv6 in combination with NAT or either translation, either NAT 4.4 or some kind of NAT 6.4 equivalent solution. So it's the businesses that aren't, or the organizations, networks that aren't deploying IPv6, make the costs for the newcomers higher. That's kind of painful, and I haven't really figured out a way around that, other than there's a little sort of prisoner's dilemma game we can play in game theory of, so therefore if each party benefits differently, how about we all support each other and make it work? I did that at Nanog 2 years ago, I think. It's a little complicated and painful, and I've forgotten the rest of your question.
Oh, and the other one was really kind of other countries picking up the price tag as well, right? If it's the dominant countries that are doing it and you don't have the EMEA markets and so forth adopting it, does it really come to fruition?
It sure looks to me like, well, essentially all of the major economies in the world have significant adoption. Significant meaning they've proven that it can work economically on backbone networks, right? There's no question. Anybody who has a backbone network is not running equipment that's incapable of IPv6. There's just, the hardware, how old is your hardware? Is it really a backbone if it's 20-year-old hardware? Now, there are certainly networks that still have routers that are 20 years old, absolutely. They don't tend to be the core of the network. It's more about the consumer electronics where I would worry about current capabilities. And that's, game consoles and stereos and smart TVs and somebody in the chat earlier mentioned IoT, where some IoT devices have great support and some have none, and it's entirely dependent really on what embedded stack, what embedded Linux version you choose and what libraries it has.
Yeah, true that, exactly. But what about the, abuse management? John, perhaps you can share some thoughts on, how frequently you, kind of solving the abuse cases for IPv6.
So here at the RIR at ARIN, we get no fraud complaints whatsoever on IPv6. So it's all around IPv4, and of course that's because of the cost of it. I really, it's been a long time. I was last at Time Warner Cable with Lee, and that was 5 years ago. And IPv6, there wasn't spam issues, there wasn't abuse issues, there was never any problems with that. I don't know what it looks like today on the inside of an ISP, what kind of abuse they're seeing on the IPv6. I know we get a lot of people complaining to ARIN through our feedback and through Hostmaster and stuff about abuse and spam, and it's always about IPv4 blocks. It's never they're getting spammed by IPv6. So.
And perhaps at some cases, some systems only support IPv4 instead of IPv6.
Especially mail servers. It's
Yeah.
There's
exactly.
Yes.
Yeah. Doesn't seem like that high
right.
Yes.
Right. So
one of those though is one reason for that is because as Lee pointed out, like all the equipment, like nobody should have to be paying extra money for IPv6 features and the equipment and the equipment they purchase and everything. That's been there for a long, long time, except for the few things he mentioned in the home. But there's a cost. There's a cost of resources, human resources, for running a dual stack network,
yes.
and the cost comes in. You get security issues in one set in your IPv4 code, and you go out there, and in the case of Time Warner, we used to touch, like, I don't know what was it, Lee, like 50,000 routers in a night in a maintenance when we had to update all the iOS on every one of those systems. And then if like 2 days later an IPv6 security came out, and we'd have to go back there and do that all again. I think that's going to be one of the things that's going to finally drive people to IPv6 myself. It's the cost of trying to run both those networks and keeping your engineers up to speed on both of those protocols. They're totally different paradigms. You've got to think of them both totally different, and it is a challenge. And it eats up resources, and especially we all know, for the most part today, I don't know any engineering teams out there that have people dedicated to IPv6 because they can afford to do that. They're taking it out of their hide, and they already have too much to do as it is.
Mm-hmm. So let me ask you a question. Do you guys really think that one day that IPv6 100% replaces v4? I think they coexist, at least during my lifetime. Right.
Will TCP/IP one day 100% replace OSI?
Right.
No, there will always be pockets of NDP or maybe that's a bad example, but there's still Banyan Vines networks out there. So there'll always be some. I think the question is when does it become truly substitutable? And
and
that was the question, actually. Yeah, that was the question for our closing remarks.
I'm stealing, I know. We'll re-ask it because you guys, I'm going to throw a fun little nugget. If it ever came out there, I don't care who the auction company is, if 1.1.1.1 ever sold, it's going to go for a record, right? I mean, just think about any nostalgic individual that wants to own that IP, right?
Well, I believe that did happen with a couple of the other, public DNS servers. They were bought in private transactions.
Yep.
All right.
So Lee,
let's take a look at that.
Yeah. Well, you wanted to add.
Sorry. Yeah, I wanted to actually take a look at where this growth in IPv6 is actually happening. I mean, this isn't happening within developed networks. Like, this isn't happening in Western Europe or in the Americas. This is actually happening in Western Asia. This last couple of years of growth has been hit there. It's really India and China that has put IPv6 growth the last couple of years on the map. It's not what you would probably think of as those developed networks that would be deploying the V6. So why is that then? And if you take a look at where the largest growth is happening, it's India, China, Mexico comes in, okay? Then Brazil. So you're talking about developing networks there, right? You're not talking about the developed networks. I think only when you start looking at Japan, so again, Asia kind of coming up with a bit more of that IPv6 adoption, right? Mm-hmm. So our Western European or the Americas networks aren't really seeing this great growth. We had the growth maybe earlier on in those networks, but it's kind of tapered off now, and you're seeing it happening there. We're not seeing the growth in Eastern Europe, Middle East, Africa, hardly at all. Right?
No chances. No chances. And actually, yes, no chances. And actually, you know, French Telecom said we're not gonna implement dual stack. You know, Lee showed me before webinar his Excel spreadsheet where he wanted to see, share, you know, which telecom companies are adopting IPv6 right now. But yeah, I mean, if we will look at the reality, you know, I have I have Lithuanian phone number and I have UK phone number. You know, none of those networks support IPv6. None.
Really?
You know,
really?
Of course
because every mobile carrier in the U.S. supports IPv6. I think that's true. Maybe one of them didn't, and they just got bought by another one. So it's something like 98% of mobile devices in the U.S. are IPv6 capable. In France, Facebook says that over 50% of hits on Facebook in France are over IPv6. Mm-hmm. Google says France is almost 50% of hits on Google properties from France are over IPv6. So somebody's deploying it there. But I think, to Paul's point, I think it's the law of large numbers. The growth isn't happening in Western countries because once you hit 40 or 50 or 60% deployments on IPv6, the last 20, 30, 40, 50%, that's much harder to reach than the first. And so growth slows down, and it is when you're building a mobile network in a developing country, it's a brand new greenfield deployment, and you're going to support, a few 100 million users. Yeah, you're probably going to want to start with IPv6 as fast as you can.
Mm-hmm. Yeah, that's a very good point, Lee. That's a very, very good point, because here in the Netherlands, we're very much like France. And I can see, if you look at the maybe top 20, 25, France does show up there, as does the Netherlands, so I can see that it's there. But that point you just raised was very much on target.
Some great notes in the chat too.
That next growth rate of what we've seen from Western Europe, that's going to take a little bit more time to see where that's going to come. I don't think we're there yet at all on that growth.
So
John, a little while. Go ahead.
Yeah, coming back to IPv4 and talking essentially about the transfer market and the lease market, we have calculated that right now IP prices are growing 23% each year. Correct me, Lee, if I'm wrong.
Mm-hmm.
It's spiky. It's been 50% in the past 6 months.
But then, exactly. It's spiky. Yeah, exactly. But when we have the whole pandemic situation, I personally think that the prices actually went up like 35% up, and probably it's going to increase even more right now due to the actual business digital transformation, due to that many people discovered that they can work remotely, and they don't need to use their offices anymore. So do you think that, these are the drivers that will maintain that IPv4 pricing growth?
So, so it seemed to me that the demand, the pandemic did not slow down demand at all in the address market, although prices held fairly flat over the course. I think that for us, at least in 2020, and by the way, we publish all of our transactions that happen on our online marketplace. We publish the prices for them. So you can see price for every transaction. And you can see that in 2020, prices were fairly flat. They grew a little bit. It's really end of 2020, we suddenly moved from about $20 per address to $23 per address. This morning, we sold the /21 for $37 an address. So that's
37.
Oh, wow.
37.
Wow.
Yeah.
Wow.
So the prices are, have increased a lot in the past few months, and so the demand is very high. There's more supply coming out. I think what's going on both is that buyers and sellers both have put a lot of projects on hold through the pandemic, right? I wasn't in the office. I couldn't physically move the hardware. I couldn't do the rewiring I was going to do. All those network infrastructure projects, they've been on hold. So now people are coming back. They're coming off hold. They're taking them back up. But buyers are getting to the market faster. Than buyers are going, okay, we're picking up this project again. We need addresses to do this project. Sellers are saying, we're picking up this project again. It's going to take us a few months to be able to make some addresses available to the market. And so I think there's a lag. This is my intuition that, again, no data to point at other than prices. I think that we're going to have, it's a pretty good time to be a seller right now.
Hey, Lee, I'm sorry.
And actually,
that pricing, was that on the Class D at 37 an IP? What was the size of that?
/21.
Yeah, and actually, since we catch up from time to time with Lee, some of the things that actually correlates with IP lease market, and being in the IP lease market, what we actually noticed that even Paul, you mentioned that IPv6, much bigger adoption is in Asia, in Latin region. But we also noticed that, for example, the companies that are based, in Asia and in Latin, many of them are okay, with their capex. But at some point, paying, let's say, $37 per IP, they don't have so much OPEX. So here comes the IP lease, where we see the opportunity scaling and perhaps investing into their hardware, but not buying the IP space. And at the same time, the companies that own a large pool, well, I would not say own, but allocated a large pool of IP addresses, they also keep those IP addresses as a strategic asset as well, right? So the aim here, I think that what we are looking at, IP lease also will going to be a popular option for the businesses to consider.
And Vincentas, do you see a correlation between lease prices and sale prices?
Yes.
Do they rise at the same curve?
They do rise. Yes.
Because I read your blog posts. I've wondered about somebody making the decision whether to sell or to lease, and how would they make that decision? I think Clara actually brought that up in the Q&A.
She did. Yep. No, I think on either side of it, there's never a better time to either sell or even lease. And I think it really kind of dictates. The easiest way I'd sum it up is if you're in the finance team, put it in Excel, drag right. And if you get to about month 28, if it makes sense at you at that point, keep your asset, because that's about where that time starts to really kind of drive the dollars and cents to make sense. If no pun, but.
So we actually doing a lot of hangouts on the different topics, but I noticed that we only left 6 minutes for us. So the question would be for you guys, and I know that there is no concrete answer to that, but what's your personal opinion? if we can name when, so when do you think IPv6 would replace? And what do you think? Will IPv4, be replaceable at all? Lee, perhaps you could elaborate on that a little bit from your perspective.
Yeah, people usually ask me almost the other way around: is when will IPv6 deployment have an effect on the IPv4 market?
Right.
And kind of the way I answer it is if you go around and poll 100 network engineers, they all say, oh, it's 5 or 10 years down the road. That's IPv6. Well, they've been saying that for a while. But even if it's 10 years from now, if it's 2030, by the time IPv6 is a viable alternative to IPv4, 5 or 10 years, whatever. So look at the sort of alluding to something Jack said earlier, alluding to the largest buyers aren't buying IPv4 addresses to assign to devices tomorrow or virtual machines tomorrow. They're buying for their 5 years out roadmap, right? They're buying some runway for themselves, and they're simultaneously deploying IPv6. So at what point, when they're 5 years from no longer needing IPv4 addresses, they stop buying, right? So when they're 5 years away from IPv6 being a viable alternative to them, they stop buying, and that may start to change the dynamics of the market. Now, I don't think organizations who are used to buying /10s and 12s, I don't think that them leaving the market is going to change things for organizations used to buying 21s and 22s. I think those are pretty different markets, but it does start to signal to the rest of the market, oh, if the big cloud providers are 5 years away from not needing IPv4 anymore, then maybe we need to get serious about having IPv6 as an alternative also. There's also, at some point, maybe you will need something that's only available over IPv6. And how much warning will you have that you need that? Probably not as much warning as time it will take you to deploy v6. So like, oh, I'm going to need this content that's only available over v6. I'm going to need this feature that I can only get over v6. And I need that within 6 months, but it's going to take me 5 years to deploy. You're suddenly kind of in a pinch. And so that's sort of the forward-looking, when should I deploy IPv6? That's sort of my working backwards strategy. All of that said, I think the market has long legs. I think that there's, IPv4 is never going to completely go away because there's always pockets of places where it's still useful. And I think that we may be likely to see a lot of translation between v6 and v4 a few years from now.
Paul, what's your take on that?
Very, very greatly. I do agree with you very much, especially with what the larger players are doing when they're purchasing address space now. I do very much agree with that. I think, from my 20 plus years in the RAR system, all the engineers I ever spoke to when we were looking at when v6 would take up its deployment, and they used multiples of 10. 10 years, then 10 years. And even recently when I'm chatting with people, they're like, oh yeah, let's add another 10 years. So again, I'm coming back to Lee, and he's one of them from that community, where the 2030, I'm looking at like, okay, we're probably going to see something happening around that space. I'm sure within that period, we're going to see something happening, maybe even something that will change the dynamic even between v4 and v6. That I don't know. I think, there's IoT poses some big issues for what happens with v6 deployment. I think some people are shying away from v6 in a lot of their IoT deployments. So, there's other technologies that are going to come into the spin again. So again, is v6 going to be the thing happening? I don't know. I also think that when you bring on newer networks, smaller networks, not the larger ones, yeah, they can probably handle all that v6. But they're probably not going to turn off their v4 channels, right? And if you look at the newer networks that are going to come on board, most of them, I would say, will probably be deploying the v4. The engineers that they're going to be looking at in any of these, maybe up and coming developing economies or whatever that are coming on board, are probably going to be v4 savvy before they are v6, right? That technology's there. It's there. It's very accessible. It's something that's known. I know you can access all this v6 stuff as well. I just don't see v4 going away completely so quickly. I think you will see something living together first before you'll see a takeover of that v4.
Do you guys ever see maybe maybe we ban all IoT devices to V6, right? And kind of free. It's kind of like the .com. Everybody still wants the .com name, even though there's whatever you want to have as a TLD, right? But do you think we get to a point where all IoT goes to the 430 trillion IPs and we keep the important stuff on the 4.3?
It's honestly from what I reckon, from what it looks like to me is somebody needs to get into whatever IoT embedded Linux kernel is that all these guys are picking up and using, and changing that to default IPv6, and that would probably just do it. I'm not a kernel programmer. I can't be the one to do it.
John, we need your opinion. Yeah, we need your answer here, please.
I always like to look at the human side of it, and I think we got to get through the current engineering group and into the next, as the younger engineers come in and start, like IPv4 is not going to be cool because that was their grandfather's protocol. IPv6 is cool. But you're going to get that human thing where you get these younger engineers. Actually, they probably like V6 better. They're going to start pushing that internally and as they become the leaders of those teams and pushing it out there and doing it. So I agree with Lee. It's probably 2030. It'll start. Something's going to be happening. I mean, it's happening today. It's gaining momentum. It's going to become a tipping point. I think that tipping point is still at least 5 to 10 years out.
Just wait till those millennials get our age and they don't want to have to remember all those numbers. That's why we want to keep V4.
But you want to joke?
They will have figured out some way easier to do it. I'm sure. They might even come up with a protocol that gets rid of IP.
Do you want to joke? Do you want to joke about the human side that you mentioned? So I spoke with a young sysadmin, and he said, "How can you work with V6? You barely can remember those numbers and letters to log into the server."
At least somebody would come up with a way to map names to numbers.
Absolutely, guys. I think we have touched. I think that we can, we could go for another couple of hours because that topic is really endless, and we could analyze inside out the facts, the data. But I think it's enough 1 hour for our discussion.
Yes.
And
beautiful.
It definitely covers the whole ecosystem what's happening, and I think that we're definitely gonna meet in fall with another series of webinar to analyze some other bits of the IP ecosystem. So again, thank you very much for joining our webinar series, and it was a blast.
Thank you.
Thank you guys for joining.
Thank you.